Okay, quick summary. We've constructed unlabeled graphs of sine and cosine functions. And what we do is we just start with a circle, center the circle at the origin of an xy coordinate system. We mark equally spaced points around the circle. Now, I didn't quite manage that. The points are not equally spaced. The last point ends up here, and there's no reason that the points should end where they started. We could do another point here and get another point on the graph, as you'll see. Okay, well, we mark those points, and then we mark that horizontal axis over here. Don't call it an x-axis. It's a horizontal axis. And we mark equally spaced points here. Now, my points didn't stay equally spaced, but you get the idea. And, of course, we're going to do the same thing down here. Here we're going to do what we call a sine curve. Here we're going to do what we call the cosine curve. Now, to get y values that go with the x values that we've marked along here, we simply take each of these points and project it over to the y-axis. So in the first quadrant, you see I've projected the points over to the y-axis, and I've obtained y-coordinates here, 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 here. Now over here, I marked those y-coordinates. I didn't actually mark them on this graph. I just took this distance here and put it here. Let me mark those points so I can be consistent with what I did. Okay, these x's here match these x's here, so that we get a series of vertical coordinates. Don't want to call this x because I'm calling this x. I don't want to call this y here because I'm calling this y. And things get a little confused down here if I use x and y for these axes. Okay, you'll see that in a second. Okay, so well, anyhow, in the first quadrant, of course, my points move further and further up the y-axis. But in the second quadrant, as you can see, the projections indicated in green, they come back down. So these green projections here, these points here on the y-axis, indicating the projections that we got over here, are going to be these green marked points here when we match them up with these x values. Okay, so we get these points, and then we do the same thing in the third quadrant. We get these orange marked points here that are proceeding as we move around the circle in the counterclockwise direction. They're proceeding downward, and we match these coordinates up with the successive x coordinates. We get these points here and purple points from the fourth quadrant, and we're going from here back toward the x-axis, so the y-coordinates are returning to 0, and we get these points here. Now, my first attempt at the graph wasn't very good. These points didn't go low enough. Also, as I mentioned, the points spread out a little more here. They weren't really equally spaced, so the points seem to have gotten further and further apart along the horizontal axis as we move in that direction. In blue, I drew the curve that corresponds to the points that I actually plotted. In red, I actually drew the curve as it really should have looked, where I drew a projection here and a projection here so that the lowest point of the curve matches the lowest y-coordinate. The highest point of the curve matches the highest y-coordinate. So the red curve is actually a fairly good sine curve, except that this half of the cycle is a little bigger than this half, so it isn't perfect. Okay, well, to do the cosine function, we just do exactly the same thing, except for the values on the vertical axis of our graph, we're going to use the x projections of the points. So we project the points here in the first quadrant down to these x's here, in the second quadrant to the green x's along the x coordinate, and the third quadrant to the orange marked points, and in the fourth quadrant to the purple marked points, and we just match up these coordinates. Okay, well, in the first quadrant, our first x coordinate, which I didn't actually mark here, would correspond to our very first point, which is on the x-axis. And the points start out here and they decrease down to 0. The coordinates of these points decrease from whatever the coordinate is here down to 0. So that our purple points, as we move along the curve, we start with this coordinate, and then this one, this one, this one, and this one as we move down towards 0. Matching these coordinates up with the coordinates on our horizontal axis here. I keep wanting to say x-axis. We can understand that. Matching these coordinates up one by one, we get these points here. And then we do the same with the green points. In other words, our coordinates decrease down to 0 and then go to the negatives. So we decrease down through the negatives. We match these points up with this, 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 and so forth. And we continue that around the circle. And we get an unscaled graph of what we call the cosine function. Now note that one complete cycle corresponds to one trip around the circle. And it's not necessary, incidentally, to construct a graph starting at this point. We could start at any point, but the graph wouldn't be just a plain sine or cosine. It would be shifted somewhat. And we can illustrate the idea of shifting just by comparing these two graphs. A complete cycle is one trip around the circle. So if we start here, then a trip around the circle ends here. Now our last point didn't quite get here. We had to go a little bit further to get back to where we started, but I kind of did that when I drew the graphs. A complete cycle corresponds to one trip around the circle. A complete cycle of the graph would go from here out to our last point, then a little further, and actually, you can understand, would end when the graph hits the horizontal axis in this case, or when it hits its high point down here. Okay, well, from here up to here is a quarter of a cycle. If we shift this graph a quarter of a cycle to the left, then the high point of the graph moves over to our vertical axis. Well, that's exactly what we have here. The high point of the graph is on our vertical axis. So shifting this graph a quarter of a cycle to the left gives us this graph. Very important property of sines and cosines.